66 million years ago, one asteroid changed almost everything about life on land. So imagine it misses. No impact winter, no sudden collapse of food webs, no mass extinction wiping out every non-bird dinosaur. Tyrannosaurs are still hunting. Triceratops is still feeding. Mammals are still mostly small. And now the obvious question appears. Would dinosaurs still rule the planet today? Maybe, but not in the way you are probably imagining, because this is not a story where Tyrannosaurus simply survives for another 66 million years and eventually walks past a highway. Species do not work like that. Even without a giant asteroid, lineages keep changing, splitting, competing, moving, and disappearing. T-Rex itself would almost certainly be long gone. Triceratops, too. The real question is whether their broader dinosaurian world would have kept producing new large herbivores and predators as climates shifted, continents moved, and ecosystems transformed. And then there is the bigger problem. Would mammals ever become giants? Would primates appear? Could anything remotely like humans evolve in a world where large dinosaurs never vanished? That is where this gets interesting. At the end of the Cretaceous, non-bird dinosaurs still occupied the biggest terrestrial roles. Huge herbivores processed enormous amounts of vegetation. Large theropods filled the top predator niches. Meanwhile, mammals were already diverse, but most were nowhere near the size of later rhinos, horses, elephants, or whales. The asteroid did not create mammals, but the extinction removed ecological competitors and opened opportunities that surviving mammals rapidly exploited afterward. So take away that extinction, and you do not just save dinosaurs. You also erase one of the biggest ecological openings mammals ever received. But here is the catch. That does not mean mammals stay as shrew-sized background animals forever. They had already been experimenting. Mesozoic mammals included climbers, diggers, swimmers, specialized feeders, and even relatively large forms that could prey on small dinosaurs. The old picture of mammals spending the entire dinosaur age as identical little nocturnal insect eaters is wrong. They were limited in important ways, especially when it came to dominating the largest land animal niches. But they were not evolutionarily frozen. So now we have a competition that never actually happened in our timeline. On one side, dinosaurs with more than 150 million years of evolutionary history behind them, already filling nearly every major large-bodied terrestrial role. On the other, mammals that had survived alongside them for ages and were clearly capable of evolving into very different ecological forms. Who wins? That is the wrong question. Evolution does not hand the planet to one team. It divides opportunities: forest canopy, open ground, rivers, coasts, nighttime, cold regions, tiny prey, giant plants. Different bodies can dominate different problems. And before we can imagine a modern world full of surviving dinosaurs, we have to solve the first major problem. What happens during the first few million years after the asteroid never hits? The first thing to understand is that avoiding the asteroid does not mean avoiding change. Earth was already changing. Huge volcanic eruptions in what is now India were pouring out lava on an extraordinary scale. These eruptions, known as the Deccan Traps, released gases that could alter climate and ocean chemistry. Exactly how much they contributed to the real extinction is still debated, but in our alternate timeline, they would still happen. So dinosaurs would not simply continue living in a perfectly stable Cretaceous paradise. Some species would disappear, others would expand, ecosystems would reorganize. And because extinction is always happening at smaller scales, the dinosaur species alive 66 million years ago would gradually be replaced by descendants and completely new groups. Think about what 66 million years actually means. Go backward that far from Tyrannosaurus, and you are nowhere near the beginning of the dinosaur story. Entire groups had already risen, diversified, and vanished during comparable stretches of time. Give surviving dinosaurs another 66 million years, and expecting them to still look like T-Rex and Triceratops would be like expecting modern mammals to look exactly like the small creatures living shortly after the real extinction. They would evolve. But into what? Climate would become one of the biggest filters. Several million years after the end of the Cretaceous, Earth entered extremely warm periods. Forests extended into high latitudes. Later, the planet gradually cooled. Antarctica developed a permanent ice sheet. Grasslands expanded across large parts of the world. Eventually came repeated ice ages. Every one of those changes would create new evolutionary problems. Imagine a lineage of large plant-eating dinosaurs facing increasingly open terrain. Dense forest is disappearing. Food is becoming more seasonal. Predators can see farther. Natural selection does not demand that the animal remain a classic Cretaceous dinosaur. Longer legs might help. Different teeth might become useful. Herding behavior could become more important. Smaller body size could help in some environments, while enormous size might remain successful in others. And dinosaurs already had the raw material for dramatic adaptation. Some could run quickly, some were heavily armored, others had sophisticated chewing systems. Theropods ranged from enormous predators to tiny feathered animals. Birds themselves are dinosaurs, and their modern diversity shows just how radically dinosaur bodies can change. That matters because one common prediction about this alternate Earth is probably wrong. Dinosaurs would not necessarily become steadily larger and more monstrous. Evolution does not move toward maximum size. Sometimes small wins. A cooling world might favor insulation and compact bodies in some lineages. Open habitats might reward speed. Islands could produce dwarfs. Forests could produce specialized climbers. Certain predators might become smaller because the available prey changed. Meanwhile, mammals would still be there, exploiting whatever opportunities dinosaurs left open. And those opportunities might be larger than expected. Dinosaurs had dominated large-bodied terrestrial niches, but mammals possessed their own advantages. They were warm-blooded, generally had highly specialized teeth, and many lineages would eventually prove extraordinarily flexible in locomotion, diet, and reproduction. If dinosaurs remained dominant on land, mammals might simply evolve around them. Perhaps large dinosaur herbivores control the plains while mammals specialize in forests. Perhaps mammalian predators become important at night. Perhaps some mammal groups reach moderate sizes without ever producing anything resembling elephants. But then Earth introduces something that neither side can ignore. The world becomes colder, drier, and increasingly covered by open grasslands. And that is where surviving dinosaurs would face a completely different planet. Grasslands would be a serious test. Grasses existed during the age of dinosaurs, but the vast open grasslands familiar today became much more important later. That shift changed mammal evolution dramatically in our timeline. Grazing animals developed teeth better suited to abrasive food. Fast runners spread across open terrain. Predators evolved alongside them. If non-bird dinosaurs were still around, they would be entering that same evolutionary arena. Some herbivorous dinosaurs already had extremely effective feeding systems. Hadrosaur jaws could process vegetation with batteries of tightly packed teeth, while ceratopsians had powerful slicing bites. Their descendants might have been perfectly capable of adapting to increasingly tough, gritty plants. Their predators would change with them, not Tyrannosaurus. Something descended from Cretaceous theropods, separated from T. rex by tens of millions of years of evolution. Maybe faster, maybe smaller, maybe feathered, maybe built for pursuing prey across open country instead of ambushing enormous herbivores. But there is an even stranger possibility. Look at birds. They are the dinosaur lineage that actually survived, and they have produced everything from hummingbirds weighing only a few grams to ostriches taller than a person. Some became swimmers, some became flightless predators, some learned to solve complex problems, use tools, remember faces, and communicate in surprisingly sophisticated ways. So, if other dinosaur lineages had survived too, intelligence would not somehow be forbidden. But this is where speculation can easily go too far. There is no evidence that surviving non-bird dinosaurs would inevitably evolve into human-like beings. Evolution has no destination. Large brains are expensive, and human-level intelligence appeared only once in our own lineage after a very specific sequence of events. Which brings us to humans. Would we exist? Probably not. The asteroid's aftermath radically changed mammalian evolution. With many large ecological roles suddenly vacant, surviving mammals diversified rapidly. Much later came primates, apes, hominins, and eventually us. Remove the extinction, and you change that entire chain. Primates might still evolve in some form, or they might not. Even if something primate-like appeared, there is no reason to expect the exact lineage that produced Homo sapiens to happen again. Change one event 66 million years ago, and eventually almost every branch above it changes too. So what if dinosaurs never went extinct? The most realistic answer is not a modern Earth covered in T-Rex. It is a planet with completely different animals. Some dinosaur lineages might still dominate large terrestrial ecosystems. Others would have vanished naturally. Mammals could still diversify, perhaps even become large in certain environments, but they would be competing inside a world whose ecological structure had never been reset in the same way. And somewhere above all of them, birds would still remind us how flexible dinosaur evolution could be. The asteroid did not simply kill the dinosaurs. It changed who got the opportunity to build the next world. And without it, that world might be so different that there would be no humans around to wonder what happened. If you want to go even farther back, check out What Ruled the Earth Before the Dinosaurs. Thanks for watching. If you enjoyed the video, leave a like, subscribe, and tell me in the comments what you think a dinosaur-dominated modern Earth would actually look like.